In this video, we're going to be talking about domain and range of quadratic functions. We have already talked about domain and range this year, so this should be a fairly easy set of notes for you today. So number 1 says the function f of x equals x squared plus 4x plus 2 is shown below. Describe in your own words the meaning of domain. Label the arrow that represents the domain. Now, remember, domain is all the possible x values of a function. So it's all the possible x values of a function. Now, when we are talking about domain, guys, and we are looking at a graph, and you are trying to determine if you should be looking left or right or bottom to top, always look at your x-axis. And we see here that our x-axis moves from left to right. So when you are determining your domain, you're looking at your graph from left to right. The next bullet point says, describe in your own words the meaning of range. Label the arrow that represents the range. So your range are all possible y values. And when we are talking about our range, guys, we go from bottom to top. Now, the third bullet point wants us to find the domain and range of f of x. So whenever we are finding domain, again, remember we are looking at our x values and we are going from left to right. So on this graph, if I go as far left as possible and I set up a boundary line here, I'm going to notice that this arrow is going to hit my boundary line. Remember, we want to think of boundary lines as pieces of paper. And when I'm hit with an arrow, remember, kind of treat that like the tip of your pencil. Your tip of your pencil is going to break through the piece of paper, and you're not going to be able to set up a boundary line there. So here, that arrow would break through that boundary. If I go as far right as possible to set up a boundary line, again, think of it like a piece of paper, I am again met with an arrow. Remember, that arrow again is going to break through your piece of paper, and you're not going to be able to set up that boundary. So when I'm not able to set up the boundary on either sides of my graph, remember, we call that all real numbers. So that's the symbol for all real numbers, or you can write out all real numbers. It's up to you on what you want to do. Okay, next let's talk about our range. So remember, our range goes from bottom to top. So if I am going to start off at the bottom of my graph, I'm at my vertex, and that boundary line is being drawn at -2. Now, if I go all the way up, then I notice I am again hit with arrows on the ceiling here. And remember, we know that when you set up a boundary line and arrows are going to hit your boundary line, that it's going to break through. So I cannot set up a boundary line there. So remember, one boundary means you should have one number when it comes to setting up your range. Again, remember your range are your y values. You're going from bottom to top. So here I'm going to say y. I'm going to leave a space for my inequality, and my boundary line was drawn at -2. Now, when it comes to the middle here, I need to determine the inequality. So to determine your inequality, you want to check to see which direction your graph opens, either up or down. If it opens up, we would say then greater than or equal to, because we have a solid line here, and especially a solid point at that boundary line at -2. If your graph opened downwards, then it would be less than. Now, guys, just an FYI, an important key feature of a graph that you want to know here is the vertex. Your vertex helps you determine the range of your graph. And what I mean by that is here you'll see that your vertex was at -2, -2. When it comes to identifying your range, you want to look at the y value of your vertex, and that helps you determine the value that your range is increasing or decreasing by, basically the maximum or minimum value there. Okay, let's go ahead and move on. Number 2, we're going to find the domain and range of the quadratic function below. So number 2, again, we want to start off by finding our domain. So remember, domain are my x values. I'm going from left to right. So if I go as far left as possible on my graph, I'm met with an arrow at my boundary line. This is going to break through. If I go as far right as possible, that boundary line again is going to the arrow is going to break through that boundary line. So here, this lets me know that my domain is all real numbers. Okay, now setting up my range. Remember, your range are your y values. We go from bottom to top. So starting off at the bottom of my graph, if I set up these boundary lines here, I am met with arrows. So here, this is going to break through. So I cannot set up the boundary line there. But if I go all the way to the top, I see here that at my vertex, I'm going to set up my boundary line at 3. That is the y value 3. So, one boundary line means we should have one number when it comes to setting up our range. So I'm going to have my y value. I'm going to leave a space for my inequality, and then I'm going to list the boundary line at 3. Now, determine if your graph opens up or down. I see that my graph is opening downwards. So because it is opening downwards, my inequality here is going to be less than or equal to. Number 3. Again, we want to start off by finding our domain. These, again, are my x values. We go from left to right. So if I go as far left as possible, setting up my boundary line, again here, I'm met with an arrow. This is going to break through that boundary line. If I go as far right as possible, setting up my boundary line, I am again met with an arrow. So again, I cannot set up a boundary there. So here, again, this tells me that my domain is all real numbers. Next, let's talk about our range, which are our y values. We again are going from bottom to top. So if I start off at the bottom of my graph and I set up this boundary at my vertex, I'm going to notice that this boundary is being drawn at -7. If I go all the way to the top, again, I notice that I am met with arrows. And because I know that those arrows are going to break through my boundary line, I cannot set one up there. So again, one boundary means I should have one number when it comes to setting up my range. I'm going to put my y value first, leave a space for my inequality. My boundary line is drawn at -7. Now, look at the direction your graph opens. In this case, my graph is opening upwards. Remember, if my graph is opening up, we associate that with greater than or equal to. Okay, so that's identifying domain and range from a graph. Let's go ahead and move on to our next, let's go ahead and open up our notes to number 4. And on this problem, we are going to check the graphs of any functions that have a domain of all real numbers. So let's go ahead and look at our first graph. So here, again, we are talking about our domain. Remember, domain are the x values. We are moving from left to right. So if I go as far left as possible on this graph, I am met with arrows. Again, that tells us that this is going to break through. If I go as far right as possible, again, I am met with an arrow. So this tells me it is going to break through. So here, my domain is all real numbers. I'm going to go ahead and check that. Guys, I hope that you've been able to observe that 9 times out of 10, whenever we are dealing with the quadratic function, it is always going to have a domain of all real numbers as long as it is not a real world example, talking about feet or time or distance or anything like that. So as long as it's a graph like this and you have arrows on both ends, it will always be all real numbers. Okay, next up, we have y equals 5x squared. So we don't know what 5x squared looks like, so I'm going to go ahead and open up a graphing window, and I'm going to type in 5x squared on my calculator. And when I press enter, I see that this is what my graph looks like. Now, I want you to remember, guys, that when you're looking at a graph, it is only fit to this box on your calculator. And so some of you may want to say that it is not all real numbers. But I want you to realize that if you zoom out on your graph, you're going to notice that your graph is going to continue to keep going on forever and ever in both directions. I can put whatever number I want to put in for x, and it's going to give me an output. So just an FYI, whenever you're talking about any type of equation, the domain is always going to be all real numbers. And just to further solidify that for you, if I press Control T and I look at my x values, because remember, domain stands for your x's, I can literally go as far as I want to on the x values here, and I'm going to have an output or a y value. So again, my domain is all real numbers for this problem. Okay, next up, looking at our next graph, here we have a real world example. Here we're dealing with feet and seconds. Whenever you have a real world example, guys, this is not going to be all real numbers. Real world examples are not all real numbers. So let's go ahead and practice finding the domain here. So again, my domain are my x values. I'm going from left to right. Here is my first point. Now, if I draw a boundary line here, my boundary line is at 0. If I go as far right as possible here, it is at 1.6. So 2 boundary lines means you should have 2 numbers when it comes to setting up your domain. So when you have 2 numbers, you want to start off by putting your variable in the middle. So here, x is my variable. And then we list out our boundaries from least to greatest, so 0 and 1.6. And then remember, our inequalities are always going to face, we're always going to have less than symbols here, because what this tells us is that our x values are in between 0 and 1.6. And if you wanted to read this individually, you would say x is greater than 0 and x is less than 1.6. But when you put them all as one statement, they end up being less than signs here, because you could read this as x is greater than 0, x is less than 1.6. So one last thing that we need to mention is that when you're dealing with real world examples, most likely these are going to be or equal to. So this is not all row numbers. Okay, let's look at our last example. Looking at this graph, again, we want to determine the domain, which again are the x values going from left to right. If I go as far left as possible, setting up my boundary, I'm met with an arrow, so I cannot set that up. Going as far right as possible, again, I am met with an arrow, so I cannot set that up. So here, my domain is all real numbers. Okay, let's go to move on. So next up, we want to find the domain and range of the equations for numbers 5 through 7. Use your calculator to graph the function. So number 5, we have 5x squared plus 10x plus 8. Now remember what I told you when it comes to identifying the domain of a quadratic function equation. Your domain is always going to be all row numbers. So just to, again, further emphasize that to you, let's go ahead and put this in our graphs. 5x squared plus 10x plus 8. Pressing enter, this is what you see on your calculator. Now again, guys, if I were to press Control T, I can see that I can literally put in any x value and I'm going to get an output. So again, here your domain is all real numbers. Okay, now when it comes to setting up your range, I'm going to close my table by pressing Control T. When it comes to setting up your range, the first thing that you want to identify is your vertex. So looking at my graph, to identify my vertex, I first need to determine, is my vertex the lowest or highest point on my graph? Now guys, remember the vertex is your turning point. So here would be my vertex, and I notice that it is the lowest point on my graph. So remember, that means it is your minimum value. So here, I'm going to go ahead and press menu. I'm going to press 6 to analyze graph, and I'm going to press 2 for minimum. I'm going to move my dashed line on the left side of my vertex. I'm going to press enter, and then I'm going to scroll over. Here, I see that my vertex is at -1, 3. So, to determine your range, again, your range are your y values. And when you are determining your range, you want to look at the minimum or maximum value of your graph, and that can be determined by the y value of your vertex, which is 3. So here, guys, if I were looking at a graph and I were to draw a boundary line, this would be at, again, 3. Here, my graph's going to continue to keep going up. So again, if I were to zoom out, my graph is going to continue going up. So I cannot set up a boundary there. So I'm going to leave a space for my inequality, and then I'm drawing my boundary line at 3. Now, look at the direction your graph opens. Your graph opens up. And if your graph opens up, then your inequality is greater than or equal to. Number 6, we have f of x equals -x squared plus 6x minus 14. So again, open up a new graph window. We are typing in -x squared plus 6x minus 14. Pressing enter, this is what your graph may look like. If you would like to zoom out, press menu 4. It's going to zoom out your graph to where you can see it a little bit better, and press escape. So again, guys, remember when you are identifying the domain of a quadratic function, it is going to have a domain of all row numbers. And that is, again, because if I were to press Control T, you can see that I can literally type in any x value, and I'm going to get an output. I'm going to get a y value. So I'm going to press Control T. This is going to close my table to where I can see my graph alone. And again, to determine your range, we need to start off by identifying our vertex. So when I look at my vertex, I notice that it is the highest point, which means it is the maximum value. So I can find that by pressing menu 6, 3. Here's my dashed line. I'm going to put my dashed line on the left side of my graph. I'm going to press enter, and then I'm going to scroll over. Here, my vertex is at 3, -5. So again, guys, your range are your y values. So here, whenever we are determining the y value of, or determining my range, I want to look at the y value of my vertex, which is -5. So guys, basically, if I were coming onto this graph, I would be setting up a boundary line at -5. I would be setting up a boundary line at my maximum value, which is the y value of my vertex. I cannot set up a boundary line at the bottom because my graph is going to continue to keep going down. So here I'm setting up my range at -5. Now, you notice that your graph opens down, and if your graph opens downwards, it is less than or equal to. So here I have a domain of all row numbers and a range of y is less than or equal to -5. Number 7, we have 2x squared minus 12x plus 9. So I'm opening up a graphing window, and we are typing in 2x squared minus 12x plus 9. Again, guys, when it comes to identifying the domain of a quadratic function, it is all real numbers unless it is a real-world situation or you have endpoints. So to determine the range, remember, I first have to start off by identifying our vertex. So I cannot see my vertex here, so I'm going to go ahead and zoom out by pressing menu 4. And now that I can see my vertex, I want to determine, is that the lowest or highest point on your graph? It is the lowest point, so it is my minimum value. So I'm going to go ahead and press menu, 6 to analyze graph, and 2 for minimum. So here I'm going to place this dashed line on the left side of the vertex. I'm going to press the enter button, and then I'm going to scroll over. And I see that I have a vertex at 3, -9. So when it comes to identifying my range, I can set up a boundary line here at my vertex, but when it comes to setting up a boundary line at the top, I know that my graph is going to continue to keep going on forever and ever. So I have one boundary line. My range are, again, my y values, and my range is being set up at the y value of my vertex, so that's -9. My graph opens upwards, so again, that means that my inequality is greater than or equal to. So when it comes to identifying the domain and range from an equation, remember, domain is always all row numbers. When it comes to setting up your range, your steps are to find your vertex, look at the y value of your vertex, and then determine if your graph opens up or down for your inequality. Okay, let's go to move on. Number 8 says, sketch a quadratic function with the domain of all row numbers and a range of y is greater than or equal to -7. So when I look at this graph, remember, guys, this means domain of all row numbers means that my graph will continue to keep going on forever and ever in both directions. What we really mainly want to pay attention to is that I have to have a range of y is greater than or equal to -7. So what that means is I have to have a boundary line drawn at -7. So this is where my boundary line has to be drawn here. So I'm going to go ahead and put my vertex at this boundary line, wherever I want to on this boundary line. And guys, since my inequality is greater than or equal to, remember, we associate with greater than or equal to going up. So I'm just going to go ahead and create a graph or a quadratic graph that's going up, and I'm going to put arrows in both directions. And that would be an example of a graph that has a domain of all row numbers, because if I set up a boundary line on either side here, it's going to break through. And my range of y is greater than or equal to -7. My boundary line should be drawn at -7. My vertex is located at that boundary, and my graph is going up. Next problem is our last problem, number 9. Maddie is hiding in the grass and launches a Nerf bullet in the air. The function h of t equals -16t squared plus 24t represents the height of the bullet over time. The first question would like us to find the domain of the function. So remember, your domain are your x values. Here we are going from left to right. So if I go as far left as possible on this graph, I am drawing a boundary line at 0. If I go as far right as possible on this graph, I'm drawing a boundary line at 1.5. So now that I have two boundaries, remember, two boundaries means I should have two numbers when it comes to setting up my domain. So I'm going to start off by putting domain, my x value, in the middle, and I'm going to list my boundaries from least to greatest. Remember here, your inequalities are always going to be pointing in the same direction. And in these real-world problems, guys, it's always going to be or equal to as well. So this is what your domain would look like. Okay, let's go ahead and set up our range. Remember, our range are our y values. We are going from the bottom to the top. So if I'm starting off at the bottom here, remember my boundary is being drawn at 0. And if I go all the way to the top at the vertex here, my boundary is at 9. So again, two boundaries means I should have two numbers when it comes to setting up my range. So here, I'm going to go ahead and put y in the middle. I'm going to list my boundaries from least to greatest. Again, my inequalities are always going to point in the same direction, and they're always going to be or equal to here. So that is the domain and range for a real world situation. Again, please remember, in a real world situation, you have to set up boundaries because, one, if this were to continue to keep going on, if this were to continue to keep going down, I would have negative feet. Remember, we don't deal with negative distance. And then if this were to keep going here, I would see that I would end up with negative seconds, and we don't deal with negative time. Okay, lastly, if a bird is flying 10 feet above the ground, could Maddie hit the bird? Okay, so remember, this Nerf bullet, its maximum height is 9 feet. If the bird is flying at 10 feet, the bullet will never hit the bird because, again, its max height is 9 feet. So we're going to go ahead and say no because the bullet's max height is... Okay, that's going to go ahead and complete the video going over your notes. Please make sure you get them glued in, and good luck on your assignment.